Let's begin with the first article. We got a science article. Mercury could have an 11-mile underground layer of diamonds, researchers say. So, Mercury mining company when? Well, it's gonna take a while since Mercury is quite a bit hot. Although I heard it's not as hot as Venus overall. Like, when you face the sun with Mercury, yes, it is hotter than on Venus. However, overall temperature, when you also count in the far side of the planet, which is not facing the sun, which has the opposite, which has very low temperature, so the overall average temperature is definitely lower than on Venus. Anyways. And yes, I already said it that, yeah, there are many materials and resources, natural resources in the universe, in the space, which is why the humanity should strive to improve its, spatial capabilities to mine those asteroids, meteors, and comets, and stuff like this for those resources, instead of, mining the bottom of the ocean for the rocks, which turned out to produce oxygen. Yeah, hopefully that's gonna get a red light, cause like when something produces oxygen, and especially when it's something like at the bottom of ocean, where we do not really have any, knowledge about anything, where we don't even know if any oxygen was produced there to begin with. Like, you should not be mining this. Like, you don't know what you might set in motion. Alright, a layer of diamonds up to 18 kilometers thick could be tucked below the surface of Mercury, the solar system's smallest planet and the closest to the sun, according to new research. The diamond might have formed soon after Mercury itself coalesced into a planet about 4.5 billion years ago from a swirling cloud of dust and gas in the crucible of high temperature environment. At this time, a fledgling planet is believed to have a crust of graphite floating over a deep magma ocean. Obviously, the Mercury temperatures are so hot, there really isn't any solid ground to land on when you're facing the sun. When you are off the sun, then it cools down a bit. However, Mercury has much faster day than we do. I believe it was like 8 hours or so. So yeah, like the things over on the other side of Mercury cool down for like few hours, then it goes straight back into the heat. A team of researchers recreated that searing environment in an experiment with a machine called envelope press that's normally used to study how materials behave under extreme pressure, but also for the production of synthetic diamonds. It's a huge press which enables us subject tiny samples at the same high pressure and high temperature that we would expect deep inside the mantle of Mercury, at the boundary between the mantle and the core, said Bernard Charrier, head of the Department of Geology at the University of Liège in Belgium, a co-author of a study reporting the findings. Yes, many years ago, maybe it's still somewhat popular now, although I doubt it, but some years ago, there was a lot of people were, trying to get rich by, making those synthetic diamonds, stuff like this. Even Mythbusters, did some experiments on this, if I remember correctly. Pretty much they found out that you would have to spend way more money than it would actually yield. Maybe technology had advanced more than enough for you to actually earn some money from it. However, somehow I doubt about it. Maybe it would, however, it would still generate you a negligible income. Besides, you would also have to tax it. Like, I don't know how it works. Maybe you could just write off a lot of the resources you buy as a business expenditure. I don't know how taxes works in majority of the nations around the globe. The team inserted a synthetic mixture of elements including silicon, titanium, magnesium, and aluminum inside a graphite capsule, mimicking the theorized composition of Mercury's interior in its early days. The researchers then subjected the capsule to pressure almost 70,000 times greater than those found on Earth's surface, and conditions likely found near Mercury's core billions of years ago. After the sample melted, the scientists looked at changes in the chemistry and minerals under an electron microscope and noted that the graphite had turned into diamond crystals. This mechanism, the researchers said, can not only give us more insight into the secrets hidden below Mercury's surface, but on planetary evolution and the internal structure exoplanets with similar characteristics. Mysterious Mercury. Mercury is the second densest planet after Earth. A large metallic core takes up to 85% of Mercury's radius, and it's also the least explored of the solar system's terrestrial planets. The last completed mission to Mercury, NASA's Messenger, orbited around the planet between March 2011 and April 2015, also known as the Mercury Surface Space Environment Geochemistry and Ranging Mission. It gathered data about the planet's geology, chemistry, and magnetic fields before spacecraft ran out of fuel and impacted the surface. We know there's a lot of carbon in the form of graphite on the surface of Mercury, but there are very few studies about the inside of the planet, said Yan Hao Lin, a staff scientist at the Center for High Pressure Science and Technology Advanced Research in Beijing and co-author of the study, which appeared in June in the journal Nature Communications. Compared to Moon or Mars, we know very little about Mercury. Also because we don't have any samples from the surface of the planet. Well, that's obvious, cause same as Venus, the the Mercury's, surface is extremely hot. They would have to land on the far side of Mercury where it is cold, and they would have to stay there for a very small amount of time, then leave back to Earth. Or funnily enough, it is still easier to get those samples from Mercury than it is from Venus. However, from Mercury you also need to have a little bit more of preparing power, I would assume. I don't know. I don't do maths for the NASA and NASA spacecrafts. Chariot said Mercury is different from all other terrestrial planets. He added because it is so close to the Sun and therefore has a very low amount of oxygen, which affects its chemistry. One of Messenger's findings was the fact that Mercury is rich in carbon and its surface is gray due to the widespread presence of graphite, which is a form of carbon. Diamonds are also made of pure carbon, formed under specific pressure and temperature conditions. The researchers wanted to see whether this process could have played out during the planet's formation. When Lin, Charia, and their colleagues were preparing the experiment to mimic Mercury's interior shortly after the planet's formation, one crucial element was the knowledge that sulfur is also present on Mercury. As evidence from previous studies had shown, we found out that conditions are different from Earth because there is a lot of sulfur on Mercury, which decreased the melting point of our samples, Charia said. There is sulfur on Mercury. I mean, I guess it makes sense because there's a lot of magnetic things going on, magnetic activity, yeah, that's the word. However, simply because Mercury is so close to the Sun, it has no atmosphere. Therefore, anything that actually goes out from that magnetic activity to pretty much anything else, well, it simply goes out into space because it cannot stay in the atmosphere of Mercury, which it has pretty much none. Basically, there's no atmosphere on Mercury, obviously, because it's so close to Sun. It fully melted at a lower temperature compared to a system without sulfur, which is good for the stability of a diamond because diamonds like high pressure but lower temperature. And this is mainly what our experiments tells us. The magma ocean of Mercury is cooler than expected and also deeper, as we know from the reinterpretation, yeah, reinterpretation of geophysics measurements, he added, referring to data from also from Messenger. Well, this is not surprising. As I said, one part of the planet is extremely hot, then the other part of the planet is extremely cool. So I would say the overall, closer to the edges of, day and night, the temperature with them is probably lower, which means there is a place for diamond structure be created for good quality diamonds, to be more specific. And these two factors, according to this study, are what makes the formation of diamonds possible. Diamonds on the surface. Charia warns that the thickness of the diamond layer between 15th and 18th kilometer is between 15 and 18 kilometers is only an estimate, and it might change because the process of formation of the diamonds is still ongoing as the core of Mercury continues to cool. It is also impossible to tell how large the individual diamonds may be. We have no clue about their size, but a diamond is made of carbon only, so they should be similar to what we know on Earth for their composition. They would look like pure diamonds, he said. Could the diamonds ever be mined? Theoretically, yes. However, practically no. Theoretically yes, practically no in the nearest future, which is like, let's say 100 to 200 years. I don't think we will be able to mine for Mercury. However, from the year 2000, let's say 280 onwards, we should be able to mine from Mercury. We should be able to mine the Mercury diamonds. However, before that, it won't be our priority. Our priority before that will be simple exploration of the solar systems and the beginning of mining processes in the Earth's orbits, and practically going to probably the Kuiper belt. I think its name is Kuiper belt between Mars and Jupiter, because it would take a lot of funds to create a mining device that would withstand the heat of the sun, and that's simply something that no one can afford at this moment. Obviously, as we are gonna get more and more rich from the mining our solar system, and as we are going to be able to progress with our technology, I think it will eventually probably mine diamonds. Well, there's also a question how diamonds are going to be useful for us. If diamonds will remain something as simple as something you put on a wedding ring, then there will be some people that will definitely mine it, because there will be people who will buy it simply because it's a diamond from Mercury. Like, people will sell it for obscene prices and people would still buy it simply because it's from an alien planet. So let's continue. Could the diamonds ever be mined? According to Charia, that would be impossible even with future more advanced technologies, because they are at a depth of about 500 kilometers. However, some lavas at the surface of Mercury have been formed by melting at the very deep mantle. It is reasonable to consider that this process is able to bring some diamonds to the surface, by analogy with what happens on Earth, he said. So yeah, he went about it a little bit different than I did, but yeah, obviously. Like 400 degrees Celsius, and so there's obviously even from a bigger depths of Mercury, the diamonds can be built up, same as happens on Earth with the volcanic activity. The question here is simple, when will we get technology good enough to mine there? As for now, it is very unlikely that we will be able to mine there in any time soon, in 100 or 200 years, but onwards it is possible, but it depends. If diamonds won't get any more practical use, diamonds have some practical uses, alright? They are not just those shiny stones, and they are used on other stuff. However, as long as general populace views them as a shiny things, I don't think there will be that big of an interest, but you never know where the technology innovation takes us. The diamond forming process might be happening on some of the exoplanets that we are discovering in our galaxy. Charia explained, if their chemistry is also low in oxygen like Mercury, if an exoplanet is smaller than Mercury, the core mantle boundary would be too shallow and the pressure would be too low, preventing the formation of the diamonds, he said. But the size between Mercury and Earth combined with low oxygen are favorable conditions to get diamonds. Scientists may know more soon. A mission called Bepi Colombo, made up to 2 spacecraft launched in October 2018, is expected to conduct insertion into Mercury's orbit in December 2025. After performing a series of flybys, the mission led by European Space Agency and Japan Aerospace Exploration Agency will study the planet from orbiter and reveal much more about its interior and characteristics. The collaboration is named after an Italian scientist Giuseppe Bepi Colombo, who invented the gravity assist maneuver routinely used to send probes to other planets. Bepi Colombo can possibly identify and quantify the carbon on the surface, but also whether there is diamond on the surface or more graphite, Sharia said. This was not possible with Messenger, and the measurements will also be more precise, giving us better estimates of the depth of the core mental boundary. We will be able to test our hypothesis again. So there will be a launch in 2025, at the end of 2025, so that's something to look forward to. I'm gonna check like what sort of interesting launches are happening in the next like 12 months or so, because I mean the last big launch I was watching was the Space Webb Telescope, and that's been some years now. An important step forward. Sean Solomon, the principal investigator for NASA's Messenger mission to Mercury and adjunct senior research scientist at Columbia University in New York City, said it presents an interesting idea, but that will be a challenge for future mission to Mercury to be able to confirm it. Any such diamond layer is deep and relatively thin, he said in an email. Solomon was not involved with the study. The most promising technique is probably seismology because the velocities of seismic waves in diamond are much higher than those in mantle rocks or core material. But seismic measurements would require one or more long-lived landers on Mercury's surface, Solomon said. Bepi Colombo, the only mission currently planned to reach Mercury, originally had a lander, but it was cut due to budget constraints. And this is the end of the article as well, so nothing really that big of a deal. So yeah, I'm gonna actually see. I'm gonna close this, and I'm gonna Mercury temperature. During the day, the temperatures on the surface can reach 430 degrees Celsius because the planet has no atmosphere to retain the heat. The nighttime temperatures on the surface can drop to minus 180 degrees Celsius. So yeah, so this is a massive range. Like how much? 740 degrees. 740 degrees Celsius range. This is very massive range. I was saying something I completely forgot about it. Sorry, but yeah, like the one side cools, the other is basically a cow. And Mercury Dayland, wait, what? Why is day? Oh, wait, so the day on Mercury is actually very long? Oh, I did not know that. Wow, and Venus is even longer. What the heck? Give me a moment. I'm gonna sneeze. Okay, so I did not know this at all. This comes as quite a bit of a surprise. Both the Mercury, but the Venus is even more surprising. Damn, I did not know that it takes such a long while for, you know, one day to pass on Venus. I actually did not know this. And those are such anomalies, actually, even. Because, like, the day on Jupiter, Saturn, Uranus, and Neptune is shorter than the Earth's. However, you can see, like, it's like 14 hours, which is like, okay, that's quite a bit. But then you look at this. What the hell is this? Like, how is this possible? What the hell? So, yeah, this might also be. It might also be one of the reasons why Venus is not habitable. Who knows? Like, this is just something I just was thinking about. Sorry, I did not know this at all. I don't think there's anything else I wanted to talk about. Probably there was something I wanted to talk about, but I forgot about it because I sneezed. And I let's move on before I'm just gonna stuck myself here.